this video lecture on one of the most essential topics in C programming, dynamic memory allocation. Have you ever wondered how programs handle data when the size isn't fixed? Like managing a dynamic names of list of names or storing real-time data. This is where dynamic memory allocation comes into play. In this session, we'll explore how C allows you to allocate memory at runtime, giving you flexibility to create efficient programs that adapt to your needs. We'll cover the key functions such as malloc, calloc, realloc, and free, along with the practical examples and best practices to avoid common pitfalls like memory leaks. Whether you're building a complex data structures like linked list or optimizing resource usage in a large application, understanding dynamic memory allocation is a skill every C programmer must master. Memory allocation in C is the process of reserving memory for variables, data structures, or objects during program execution. So there are two main types, static memory allocation and dynamic memory allocation. So static memory allocation, it is where memory is allocated at compile time, such as with global and local variables. Advantages of static memory allocation. Number one, faster execution. Since memory is allocated at compile time, the allocation and the allocation processor are quicker compared to dynamic memory allocation. This reduces runtime overhead, resulting in faster program execution. Number two, predictable memory use. The size and location of the memory are determined at compile time, making it easier to predict and manage memory usage. This predictability is especially beneficial in systems with limited memory resource. Number, number three, automatic deallocation. Memory allocated statically is automatically deallocated when the program or the function scope ends. This eliminates the need for manual memory management, reducing the risk of memory leaks of dangling pointers. Plus, simple implementation. Static memory allocation requires no additional code or functions for managing memory, as everything is handled by the compiler. This simplicity makes it easier for beginners to understand and implement. For the disadvantages of static memory allocation, first we have fixed size. Memory size must be defined at a compile time and it cannot be changed during program execution. This can lead to inefficiency, wasted memory, or insufficient memory. Next, stack limitations. Static memory allocation typically uses the stack, which has limited size compared to the heap. Large data structures or deeply nested can cause stack overflow, leading to program crashes. Last, reduce flexibility. Static memory allocation lacks the ability to adapt to changing program requirements or dynamic data sizes at runtime. This makes it unsuitable for applications that need to handle variable amounts of data such as user input or real-time processing. Now let's talk about our main topic, dynamic memory. Memory is allocated during runtime, which allows for flexible and efficient use of memory. Since C is a structured language, it has some fixed rules for programming. One of them includes changing the size of an array, the, M- and the image. Now let's talk about our main topic, dynamic memory. Since C is a structured language, it has some fixed rules for programming. One of them includes changing the size of an array. The image illustrates the fundamental structure of an array, a contiguous block of memory locations, each holding a specific value. This concept is directly applicable to the memory allocation. Some facts about dynamic memory allocation are dynamic memory is a memory that is allocated after the program starts running. Allocation of dynamic memory can also be referred to as runtime memory allocation. Unlike with static memory, you have full control over how much memory is being used at any time. You can write code that determine how much memory you need to allocate it. Dynamic memory does not belong to a variable. It can only be accessed with pointers. Now let's move on to the advantages and disadvantages of dynamic memory allocation. Advantages of dynamic memory allocation. Number one, flexible memory management. Memory can be allocated and resized at runtime, allowing the program to adapt to varying data sizes. This is particularly useful for applications where the exact memory requirements are unknown beforehand, such as handling user input or working with data structures like linked list or dynamic arrays. Number two, Efficient use of memory. Unlike static memory allocation, where a fixed amount of memory is reserved regardless of actual usage, dynamic memory allocation ensures that only the required amount of memory is used. This minimizes memory wastage and optimizes resource usage. Number 3. No stack limitations. Dynamic memory is allocated from the heap rather than the stack. Since the heap has significantly larger size, dynamic memory allocation overcomes the size limitations of the stack, making it suitable for managing large datasets or complex data structures. Number 4. Lifetime control. Dynamically allocated memory exists until explicitly deallocated using free function. This allows the programmer to control the lifetime of the allocated memory, enabling the development of sophisticated and long-running programs where memory usage needs to be precisely managed. Now let's discuss the disadvantages of dynamic memory. Number 1. Slower execution. Allocating and deallocating memory dynamically involves additional overhead during runtime. Functions like malloc and free interact with the system's memory manager, making dynamic memory allocation slower than static allocation. Number 2. Manual deallocation required. Unlike static memory allocation where memory is automatically deallocated, dynamic memory allocation requires the programmer to explicitly free unused memory using the free function. Failing to do so leads to memory leaks, which can cause programs to consume excessive memory over time. Number 3. Complex management. Managing dynamically allocated memory can be challenging, especially in large programs. Programmers must carefully track and deallocate memory to avoid issues like memory leaks, dangling pointers, or double freeing, all of which can lead to unidentified behavior. Number 4. Fragmentation. Over time, frequent allocation and deallocation of memory blocks can result in fragmented memory. This occurs when free memory is split into small, non-contiguous chunks, making it difficult to allocate larger memory blocks even if insufficient total memory is available. Next, there are 4 library functions provided by C defined under studlib.h header file to facilitate dynamic memory allocation in C programming. They are malloc, calloc, free, and realloc. Malloc. The malloc or memory allocation method in C is used to dynamically allocate a single large block of memory with a specified size. The function returns a pointer of type void, meaning it doesn't specify the data type of the memory block, so you can cast it to any pointer type you need, for example, int or float. However, malloc does not initialize the allocated memory. Instead, the memory will contain random or garbage values until you explicitly set or initialize it in your program. Makikita natin dyan sa syntax, yung PTR, this is the pointer that will hold the address of the allocated memory. It must be a pointer type appropriate for the data you intend to store in the allocated memory. Sa cast type naman, it ensures that the return value of malloc is correctly interpreted as a pointer of the desired type, like yun nga, cast type. So it is required because malloc returns a pointer of type void, which is a generic pointer type. The type cast makes this pointer compatible with a specific pointer type that the programmer intends to use. Yung size naman, this function call requests a block of memory from the system with a size specified by size in bytes. The size argument determines how much memory to allocate. So if malloc successfully allocates the memory, it returns a pointer to the beginning of the block, and if the memory cannot be allocated due to lack of available memory, malloc returns null. Next, we have calloc. Calloc or contiguous allocation method in C is used to dynamically allocate the specified number of blocks of memory for the specified type. It is very much similar to malloc, but it has 2 different points, and these are number 1, and it initializes each block with the default value 0, and number 2, it has 2 parameters or arguments as compared to malloc. So sa syntax naman, same with malloc, we have ptr or yung pointer, then the calloc function, then yung n is the number of elements you want to allocate, and the less element size or the size of element you want to allocate. Next ay free. Free method in C is used to dynamically deallocate the memory. The memory allocated using functions malloc and calloc is not deallocated on their own. Hence, the free method is used whenever the dynamic memory allocation takes place. It also prevents memory leaks, which can lead to program crashes due to insufficient memory, reduced program performance, and system stability. Sa syntax, a very self-explanatory free function, tapos yung PTR, it is the pointer which hold the address of the memory block that was previously allocated using the malloc and calloc or the realloc. Last, we have realloc. Realloc or reallocation method in C is used to dynamically change the memory allocation of a previously allocated memory. In other words, if the memory previously allocated with the help of malloc or calloc is insufficient, realloc can be used to dynamically reallocate memory. Reallocation of memory maintains the already present value and new blocks will be initialized with the default garbage name. Realloc also adjusts the size without needing a separate function if you want to shrink the memory block. To wrap up, dynamic memory allocation is a powerful tool in C programming that allows you to manage memory efficiently and flexibly at runtime. By understanding and effectively utilizing these functions, you can create data structure of varying sizes during runtime, optimize memory usage by allocating only the necessary amount of memory, and avoid memory leaks and improve program stability. Thank you for watching.